We have something in logic. So if you take a logic class, you'll do a lot of this, but there's also a bunch of this in math because math is logic, and it's called a conditional statement. And they're of the form if then. It's a cause and effect relationship. So it's usually like if P, then Q. Like, so if you do all your homework, then you can go out and go to the movies. Or something, you know, like that. Sometimes it says, it's more of, if you want to go to the movies, then you have to do your homework. So it's kind of reversed, but that comes up later. But if then, so if P happens, then Q will happen. Okay. A hypothesis has kind of two definitions. It's an unproved theory, proposition, or a supposition. And if you're talking about a conditional statement, it's the if part. So if I say, if you clean your room, then you'll get allowance. The hypothesis is, the unproven theory is that you will clean your room. Or the supposition that you'll clean your room. I tell my son that all the time. It never happens. That's why it's a hypothesis. It's not necessarily true. The conclusion is the last part. That's the then part. So in that statement, if you clean your room, then you will get allowance. The conclusion is you get allowance. And then a counterexample is anything that shows it to be false. So if I tell my son, if you clean your room, you will get allowance, and then he cleans his room, and then I don't give him allowance, my not paying him is a counterexample. Or, you know, you could say, like, your bank account is empty, so you can't pay him. That's a counterexample. You know, things like that. Anything that proves the statement to be false is a counterexample. So examples are true, counterexamples are false. All right, so if I make a conditional statement, if you study, then you is not with a W, it's with a U, will pass the test. This is my conditional statement. If, then. If you study, then you will pass the test. My hypothesis is that you're going to study. My conclusion is that you will pass the test. A counterexample will be you studied, then failed. That would be a counter. I studied, but then I failed. And it doesn't have to be necessarily that you even took the test and you failed it. You could just never ever take the test and you failed it. That's still a counterexample. Like, I studied, but I never came and took the test, so I failed. It's still a counterexample. Does that make sense? So then we have a converse, which is a conditional statement, but they're reversed. It's if Q, then P. Okay, so it's just flipped. It's like turned around. And here's how I remember that. Do you know how the Converse tennis shoes have the circle on the inside? But it makes more sense that it should be on the outside? They're flipped. Does that help? Okay, that's how I remember it. Converse flips, and Converse shoes have the circle on the inside, which is flipped from where it should be. Okay, a biconditional. A biconditional is a true conditional statement and a true converse statement. Sometimes the conditional will be true, but the converse will be false, or vice versa. The conditional is false, but the converse is true. To be a biconditional, they have to both be true, and then it becomes an if and only if. You will have the new PlayStation 4 if and only if you have enough money to buy it. They both have to be true, right? Like, okay, an inverse happens when you negate both parts. And inverses are opposites, and so the opposite of a positive is the negative. So it's if not P, then not Q. Now, I had said if my son, like if you clean your room, then you will get allowance. Well, if you don't clean your room, then you will not get allowance. These are the same truth as the conditional. So if the conditional is true, the inverse will be true. If the conditional is false, then the inverse will also be false. The converse may or may not be the same as conditional, may or may not have the same truth. Okay. And then you have a contrapositive. A contrapositive is an inverse statement that interchanges the hypothesis and the conclusion. So the contrapositive is an inverse and a converse at the same time. So if not Q, then not P. So this is inverse plus converse equals contrapositive. So for our example, for our, oh, I have to use the same sentence, sorry, because remember it was if you study, then you will pass. This was our example. Okay, so the converse of that is if you pass the test, then you studied. Now, okay, we're going to assume at this point, okay, let's say the conditional statement is for a fact true. If you study, you will pass the test. That's true. The converse is if you pass the test, then you studied. Is it possible to pass the test without studying?
Yeah.
Right, so this statement is not necessarily true, even though the first statement is for sure true. So that's why I'm saying the converse and the conditional statement don't always have the same truth value. It might be true if the, you know, they might match, but then they might not. Now the biconditional, okay, both the conditional and the converse have to be true. Okay, I'm not going to be able to use this example because it's not necessarily both of them true. So I have to come up with a different example for this one. So for my biconditional is if you were born in Florida. Oh, wait, no, sorry, not if you were born in Florida. Now I'm getting myself all bleh. Oh, darn it. That's the example that I had typed before, but I don't like it. So we'll go back to black. You are a Floridian. If and only if you were born in Florida. Born and live. There. Okay. If and only if, you don't have to write this out if you don't want to. In math, we don't like writing words, so we use if with two F's. This is if and only if. So if you write IFF, I know that you mean if and only if, and you never have to write if and only if again. Okay, so now we're going to go back to our if you study, you'll pass example. And we're going to use the inverse, which is if you don't study, then you will not pass. Okay. Inverses are opposites. So if it's a yes, if you do, then you will. Then it's a if you don't, then you won't. They're opposites of each other. And the contrapositive is the inverse plus the converse. So that's inverse plus converse. So it's if you do not pass the test, then you did not study. This some more conditional statements, right? They're really important in geometry. They're really important in other math too, but we're talking about geometry right now. It's the foundation of logic. People use conditional statements all the time and don't even know they're doing it. Parents, teachers, politicians, you know, your grandma, everybody. Okay, so if Marina does all her homework, then she'll get an A in the class. This is a conditional statement. Is it true? Maybe. Not necessarily though, right? Because she could do all of her homework and still fail because she failed all her tests. Right? So the hypothesis though is Marina does all her homework. That would be the hypothesis. And then this is the conclusion. Okay. Recording. Okay. If Marina does not do her homework, then she will not get an A. And the contrapositive is both. You flip and you negate. So if Marina does not get an A, then she did not do her homework. And any of these can be proven false if you find a counterexample. They may or may not be true. Here's the thing. To prove something is true, you have to prove that there are no possible counterexamples. It is much easier to prove something is false. You only have to find one counterexample, and it's false. So if you can find one situation where Marina does all of her homework but doesn't get an A, then it's false. Are both of these true? If you are a native Floridian, you were born in Florida. If you were born in Florida, you're a native Floridian. Yes. They're both true, so I can create a biconditional statement. You are a native Floridian if and only if you were born in Florida. Oops, that's up here. Okay, so if the conditional and the converse are both true, then you can make an if and only if statement. And remember this part right here, you don't have to write out this long four sentences anymore. You can just write 3 letters. We're lazy. Okay, a triangle has 2 congruent sides. That's if, so that's the hypothesis. And then it is isosceles is the conclusion. So, okay. No, this is just, you don't have to write these down though. I just want to make sure you understand them. Okay, converse. Remember converse is we flip it like the shoes? If Sheila is a dog, then she's a terrier. Okay, this one, the conditional, that's true, right? If she's a terrier, she's a dog. That's true because terriers are dogs. But if she's a dog, then she's a terrier. That's not necessary. That's not true. We can find an example that's not true. Sheila is a German Shepherd. You know, then she's not a terrier. That's a false statement. This statement is false. This statement is true. Okay, write the inverse of the following. So inverse is, so this is flip. This is negate. So if it is not raining, then Charlie does not carry an umbrella. Yeah, as long as I understand what you're talking about, you're good. Does that make sense though? You can just put the knots in there. Okay, and then contrapositive is both. This one you'll have to say, okay, if Lauren does not wear a dress, then she is not a girl. Is this true? No. Right? Because I'm looking around. There's not a single girl in here wearing a dress. No. No, you're not wearing a dress, are you? No. So. Okay, so now is the conditional true? If Lauren is a girl, then she wears a dress? No, neither of these are true. Necessarily, because there's a lot of girls that never wear dresses.